Welcome back to Math 13X lesson number 11 about basic probabilities. So we start with a birthday. What's the probability that somebody was born on a Wednesday? So first of all, make a little fraction, and since we're talking about days, there's a total of 7 days. So the total always goes on the bottom. So there's 7 days total. And out of those 7 days, only one of them is a Wednesday, which I guess I should have capitalized, but that's okay. So one Wednesday out of 7 days per week. And then I just need a calculator and say 1 divided by 7. So probabilities, you can just leave the decimal answer, or you could write it as a percent if you want to. I'm just going to leave the decimal answer. So it is a 0.143. And then if you wanted to, you could rewrite that as 14.3%. Next up, what's the probability that a person was born A in April? So you might just say, well, there's 12 months in a year and April is one of those, so the answer is 1 out of 12. Except some months are worth more than others. So I use this. January is a big one, February is a small one, March, April is a small one. May is a big one, so May's 31. April is a small one, so April's 30 days. So this is 30 days. And there's a total of 365 days in a year. So 30 days out of 365. Now with the 365, you may say, what about leap year? So that means that technically there's 365.24 days in a year, but let's just go with 365 days in a year. It's not really going to change the answer by much. So if it's 30 divided by 365 days in a year, then the answer is going to be 0.082. And if I did consider that a year is actually 365.24 days, it's not going to change the answer, at least not for the first 3 decimals. So that is going to be a 0.082. That's part A. And then part B. Well, now it's down to a specific day, and there's only one of those, April 17th each year. So there's only one that is April 17th out of the 365 days in a year. And so the chances that somebody's birthday is April 17th, 1 divided by 365 is pretty small, 0.003. So if 2 randomly chosen people met and they said, hey, my birthday's April 17th, what about you? And the second person says, hey, mine's April 17th. The chances of that happening are less than 1%, only a 0.3% chance. Okay, on to the second type of problem, and that is, what if you have a little table like this? So people were asked if they recognized the brand name Xerox. So Xerox is a company, I think they're still in business. They used to be famous for making photocopy machines. So in fact, when I was younger, instead of saying photocopy, you would say, could you Xerox a copy of that for me? So it was like a brand name that used to be so well known, but not so much anymore. So with this table, either yes, they recognize the brand name, or no, they don't. So this is sort of a marketing research. Do people still recognize this name? And then there's the males and the females. The first thing I need to do is add up all 4 of these squares to find out how many people were in the survey altogether. So we've got a 52 plus a 103 and also 49 plus 101. So that's a grand total of 305 people. So that's the first thing before I even get to the question. The total equals 305. or most places in statistics we just call that n. The sample size is 305. Next up, find the probability a person would be male and also they did not recognize the name Xerox. So that's talking about males, so that would be the 52 and the 103. But the person also did not recognize the name, so they said no. So if it's supposed to be male and they said no, then that's 103 people. So that would be 103 people out of 305. And what does that equal? 103 divided by 305. So that is a 0.338. 0.338, or in other words, 33.8% chance that the person was male and did not recognize the name Xerox. Next, so this is saying that the person has to have both qualities. They have to be male and also they have to have said no. So that means it got narrowed down to just those 103 people right there. This one is saying that they could do either. So they could either be male or they could say no. So did not recognize means that they said no. So first of all, the males. Good time for the red pen. So for males, that would be this one and this one. So there's the males. Or they could say no. Well, the people that said no are this one and this one. And since I already circled this one, I'm not going to circle a second time. That means I need to include these people right here, the 101. So then if I want to show my work, I can even say, all right, I'm going to add together the 52 plus the 103 to say those are the people that are male. And for the ones that say no, it would be 103, but I don't want to double count that, plus the 101. And then divide that by the total, which is 305. So 52 plus 103 and 101, that means the top is 256. Divided by 305. And then finally, as a decimal, 256 divided by 305 is a 0.839. Okay, on to the last one. Now this one is slightly different because it's now two people. So this was a person and this was a person. So each one of these were for one single person, and now this is two people. And they both recognized the name Xerox. So that means that they both would say, yes, I recognize the name Xerox. So if I add those together, that's a 52 plus a 49. So that's 101. So 101 said yes. Let me get that back on the camera. 101 said yes, they recognized the name Xerox. So if you're going to choose a person that says yes, they recognize the name Xerox, then the first fraction would be 101 out of the 305 total. And now the second person also has to say yes, they recognize the name Xerox. And when you have and, so it's got to be the first person says yes and the second person says yes, the word and turns to multiplication. So quick rule is when you have more than one and they both have to do the same thing, then it means the first one does it and the second one does it. And the word and turns to multiplication. Now for the second person, I actually need to take one person out of here because there's supposed to be two people, which means they're not the same person. They are two different people, which means this person was already taken out of this group of 101. That means there's only 100 left. And the total now is down to 304 because that first person had already been chosen. And now multiply these two fractions. So you could do 101 divided by 305 and then times the 100 divided by the 304 and get the answer 0.109. Or you could also put it in parentheses and say, here's the first fraction divided by 305, and then here's the second fraction divided by 304. And if you do it in parentheses, you get the same answer. So it is a 0.109.